Alright, for 3.4, I'm going to do 5 different problems. It's a great section to get some help with. You want to make sure that you're comfortable solving both exponential and logarithmic equations. And so I'm going to look at 3 kind of exponential equations to start with, and I'll do 2 logarithmic. So I'll show you what they look like so you can take a look at it or fast forward to the ones you want to see. Going to solve one exponential equation, kind of a standard setup, nothing special. Another one where the trick is it's another exponential equation, but it's in quadratic form so it can actually be factored. And then there's another one where it's an exponential equation where you have the variable you're looking for is not only in the exponent, but it's also in the denominator. So you have to do a little cross multiplying and solving. And then the logarithmic equations I'm going to solve, they're both very similar. One will look something like this. You have 2 logarithms set equal to 1, going to have to combine them together and solve. And same for this one. Eventually going to have to combine together and solve. It's just a nice sampling of the types of problems that you'll see in the homework for section 3.4. So to start with, I'm going to look at number 1 here, the first one I have written down. That's solving negative 14 plus 3e to the x equals 11. Of course, first thing you need to do is identify that it actually is exponential. Most of the problems you're going to get, well, probably all the problems you get today are either exponential or logarithmic, and you look at the variable. The variable is either in the exponent, which means it's exponential, or it's what I would say is inside the log, which means it's logarithmic. So, and the reason you need to identify it is because we said there's a specific thing that you have to do. When it's exponential, at some point I'm going to have to take the log or natural log of both sides. Maybe not going to do it right away, but I know that that's what I have to do. And then when it's logarithmic, I know that I need to switch forms. I probably want to switch it to exponential. So that's why I always say it's important to identify. Looking at that one, I know immediately going to have to take the natural log or log of both sides, but before I can do that, I want to get the base by itself. So when I look at this, I see x, sure enough, but I notice the base is e, so I need to get that by itself. So realistically, this is what you're doing. You're going to try to get that e to the x by itself, and almost like you're solving that for x, you're going to solve this for e to the x. Same steps. So if you would add 14 here, well, you're going to do the same thing here. So I'm going to add 14 to both sides, which gives me 25. And then let's say I did that over here. I would then want to divide by 3. Well, same thing here. I'm going to divide both sides by 3. And then over here I'd be done. I would already have what my x value is. Of course, that's really not what we're trying to do. We're trying to solve this one. Since x is still up in the exponent, I'm going to use my power property and say, well, if I take the log or natural log of both sides, because I have a logarithm, it allows me to bring that variable or that exponent out in front. And that's what I want to do, is I want that variable out of the exponent if at all possible. So that's going to give me x times the natural log of e is equal to the natural log of 25/3. And then if we remember that natural log is base e of e, that's really just a 1. So it's 1 times x, so it's really just x is equal to natural log of 25/3. It's why I always use natural log instead of log, but it would still work if you use log. Alright, so I already have what x is equal to. It's equal to natural log of 25/3. I'll go ahead and take out my calculator and plug that in. Natural log of 25/3. Hit enter. And I think the book says to round it to 3 decimal places, so we'll do the same. But as long as I always say go out to 3 or 4. So it looks like 2.12, it would round to 0. So I'm just going to go to 4. So 1203. So if you go to 3, that's fine. On the test, you're always welcome to ask. Like I said, in general, if you go 3 or 4, that's fine. I'll be able to follow your work to see if you're accurate anyway. Alright, next one. It's another exponential function, and I know that again because I have a variable in the exponent. Difference with this one is I have 2 different exponents. So I can't do like I did up here where I just isolate e to the x and then take the natural log of both sides. I'm not going to be able to get this e to the x by itself without having another e to an x power on the other side. So here what I have to recognize is this looks a lot like this. Or I need to be able to see that it looks a lot like this. Imagine if I replace that e to the 2x and e to the x with x squared and x. I think we all recognize, or hopefully recognize, that this factors into x minus 5 and x plus 1. Similar idea, when we looked at quadratic form, we said if this exponent is twice as large as this one, which it is, that means it's in quadratic form. And then whatever this one is, the smaller one, that's what this factor is. That's why this is x here, because of this term. So when I factor this exactly the same, it's going to be something minus 5 and something plus 1. It's e to the x minus 5 and e to the x plus 1. So that's kind of the trick with that problem. It's something you have to be able to recognize. If you don't recognize it, you're going to kind of be stuck and there's nothing you're going to be able to do. And then like I would do over here, if this equaled 0, I would set that parenthesis equal to 0 and solve it. I would set that parenthesis equal to 0 and solve it. I do the same thing. So I'm going to take e to the x minus 5, set it equal to 0, and solve it. So of course I'm going to add 5 to both sides. And then I noticed, like I did in the previous problem, x is still up in the exponent, and the only way to get it out of there is to take the natural log of both sides. So now I have x times the natural log of e, which we know is 1, is equal to the natural log of 5. And so you can say your answer is natural log of 5, or type that in, you get 1.609. So this is approximately 1.609. So there's one answer. Then of course I do the same thing with the other term. If I set that equal to 0, I would have to subtract 1 from both sides. Go ahead and take the natural log of both sides like you're supposed to do. And then of course that should be something should jump in your mind and say, wait a minute, I'm not supposed to be taking the log of a negative number. Now if you don't recognize that, you'll get lucky, because when you go to type in the natural log of a negative number, your calculator is going to tell you there's an error. So hopefully you'll recognize that, but if you don't, the calculator will catch that for you. All that means that this is not possible. There is no solution to that. This is the only answer that I'm going to have. And that doesn't always happen. It just depends on what it factors into. You may have two answers. You may not have any. They may both not work, and you'd say no solutions. Alright, so big trick with that one. Recognize that it's in quadratic form. The third one, or last one on this side, is, it's another exponential function. So again, I'm telling myself, I have to take the natural log of both sides eventually. Well, if you were solving this problem, you probably would want to get the variable out of there, so you would cross multiply. Same thing. It's a quantity, but it doesn't change what I do. So I'm going to cross multiply. So bring the implied 1 up here. It's still going to give me 400. Bring that quantity up over here. And then it's kind of your choice in terms of how you want to solve this, as long as you follow the algebra correctly. I can go ahead and distribute the 350, which I'll do here. That'll give me 350 plus 350 e to the negative x. And then I can subtract 350 from both sides. And now if you get it to this point, this looks very similar to the first example where I'm trying to get that by itself. So I'm going to go ahead and divide both sides by 350. And then, of course, I can chop a 0 off here if I want to. 5 divided by 35 I know is going to be 1/7 e to the negative x. The fact that that's negative x, you could change it to 1 over e to the x. I don't have to. I can take the natural log of both sides, bring that negative x down in front. This is still 1, so it's going to give me just negative x. And then I have the natural log of 1/7, which I can plug in my calculator. I just have to remember to multiply or divide by a negative number. So I type in natural log of 1 divided by 7. It ends up giving me negative 1.9, and you can read it there. And then I would have to multiply or divide by negative 1, so of course it's going to make it positive. So my x is going to be approximately positive 1.94. If you want to go with the calculator says, it would be 4.6, or if you want to say 5.9, that would be fine. Alright, now I said that you had a couple options here. If you want to do what I did here, there's nothing wrong with that. Another thing you could have done is you could have said, well, these are two things being multiplied together. Why don't I just divide both sides by 350 right away? And that's obviously fine. You can do that. That would give me 400 over 350 is equal to 1 plus e to the negative x. This you can simplify if you want to. I can chop a 0 off. I know that 5 goes into 40, and 35, it would go in there 8 times into 40, 7 times into 35. If I eventually subtracted 1, I would end up with 1/7 is equal to e to the negative x. And then, of course, if you look over here, that's basically what you had right there before I took the natural log of both sides. So it's kind of whatever comes to you. If this comes to you first, distribute, then go for that. If it doesn't, if dividing comes to you first, then go for that. Both of them will work as long as you do your algebra correctly. Alright, so that was solving exponential equations. Now we're going to be solving logarithmic equations. In logarithmic equations, we always know that this and this have to be positive. So for a logarithmic equation, when I get to my final answer or answers, I'm going to have to check my answer, just because I know I can't get -3, for example. I can't take the natural log of -3. Alright, so the idea is, do these have the same base? And any of the problems that you do, for at least right now, they will. Which is good. That means that allows me to combine them together like we did in the last section. So I can say that this is actually the natural log of x times x plus 1. That's what's happening on the left side. I still have the equals 1, I'm just ignoring that for right now. Well, just like if you were solving this, you would want to switch to exponential form and say that it's base e to the first equals x. Same idea over here. It's still base e to the first. It just doesn't equal x, it equals that entire thing. And I'm going to go ahead and distribute the x. Since it's got an x squared, I'm eventually going to want to factor or use a quadratic formula. I want to set this equal to 0. Now that's not a very nice number, but that's okay. If you remember in class, we said that e was approximately 3.718. You can either leave it as e or you can change it to 3.718, whichever you prefer. Obviously, since that's not the nicest number, you're probably going to have to use the quadratic formula. So, quadratic formula, it's going to be x is equal to negative b, so negative 1, plus or minus the square root of 1 squared, which I know is 1, minus 4 times a, which is 1, times c, which is negative 3.718. And like I said, I don't care if you use e or you use that approximation. Whatever you have, if you're using e, I'll plug it in my calculator and have more decimal places. If you use that number, then I'm assuming that you're rounding. Alright, and then it's divided by 2a, which is going to give me 2. Alright, continuing to simplify inside the radical. Obviously I've got 1 here. I've got 2 negatives. So when I multiply these numbers together, it should give me a positive. So 4 times 1 times 3.718 should give me a positive 14.872. And that's still over 2. Now when you're doing this, if you get a decimal that's 5 decimal places, I would say keep all 5 decimal places to be as accurate as you can. I want 2 specific numbers. I know a lot of times we like leaving the radical, but I would like to know the 2 numbers because I have to check my answer for this. So I'm actually going to figure out what the square root of 14.872 is. And you notice I'm typing it to the 1/2 power. Remember, that's another way of saying square root. Obviously you don't have to do that, that's kind of up to you. But that's going to give me negative 1 plus or minus, that is 3.8564. Remember, I always said I always go to 3 or 4 decimal places. I recommend that you do the same thing. And then to find your 2 answers, you're just going to plug them both in. So I will have negative 1 plus 3.8564. I probably don't need to actually type that in my calculator. Go ahead and hit enter so that you get your numerator, and then divide by 2. And so you end up with one answer of 1.4282. The other answer, if I take negative 1 minus 3.8564, I'm going to get negative 4.8564 divided by 2, and I end up with negative 2.4282. And then for these, remember I said you have to check your answers because they're logarithmic. I can't have a negative number in that position. So even though this number will make that statement true, if I try to plug it back in, it won't actually work. They will not give me a real number. This one will. As long as I did my algebra correctly, since this gives me a positive number in both of these positions, I should be right. You can easily plug it in and evaluate it if you want to. You don't need to do that. I'm just looking at your work to see if you know what you're doing. Like I said, if you didn't make any algebra mistakes, that will be the right answer. And then the last one, taking a look at solving this one, very similar other than this is not a number. Now you can do 2 things. I'll show you what I like to do first, and then I'll show you what you also could do, and you guys will probably like that better. I always, when I have a bunch of logarithms and not just a number, I set it equal to 0. So I'm going to subtract this term over to the left. So I'm going to say this is log base 2 of x plus log base 2 of x plus 2 minus log base 2 of x plus 6, since I'm subtracting it. And of course it now equals 0. I'm going to combine all of them together. I see they all have base 2, which is wonderful. I see a negative here, so this is in the denominator, those 2 in the numerator. So it's x plus 2 multiplied together in the numerator, x plus 6 in the denominator, still equals 0. And don't get confused by looking at something like this that has a lot of stuff going on. It's still one term. So I'm still going to switch this to exponential and say it's 2 to the 0 power, which of course is 1, is equal to that quantity. And then because you still have a variable sitting in the denominator, it would be a good idea to cross multiply. So I'll cross multiply. I'm going to need to multiply this out so I can combine like terms if I have any. And since I have a quadratic, I recognize, well, set it equal to 0 in factor or quadratic formula. So if I subtract x, that'll give me 1x, subtract 6, and for this particular one, I get lucky. I can factor this one. If you don't, you get to use a quadratic formula again. And then you set both terms equal to 0 and solve, and you don't necessarily need to show me the work for that. I know I'm going to get negative 3 and 2. And when I'm solving, again, remember you have to have a positive number in each of these positions. So if you plug negative 3 in here, that's not going to make sense. I know that one doesn't work. That doesn't mean that every negative number is automatically crossed out. It just means if you plug it back in, like say this one, say those two, for example, don't exist. If I plug negative 3 in here, it's fine. It would give me positive 3. I can take the logarithm of base 2 of 3. It's just that those two don't allow it. Alright, so now if I plug 2 in here, that would give me a positive number, positive number, positive number. As long as my algebra is right, this will be the right answer. Alright, the other thing I said that you could do, when you look at this, you might remember we have a formula that says something like this. Log base b of m is equal to log base b of n. If that's true, if you have one log on each side and they have the same base, these logarithms cancel. That's the one-to-one property that we talked about. We can say that m is equal to n. Well, when you look at this original problem, it's close. There's your equal sign. There's one log, but you've got 2 over here. If you drop the logs right now, you will not get the right answer. And that's the most common mistake, is everyone says, oh, just drop all the logs. So if you're going to use this property, you need to be careful. You can use it, but you have to combine these two together first. So if I had done that, I would have log base 2 of, let's say I multiply it out, it would be x squared plus 2x. That would then equal log base 2 of x plus 6. Now that I have just one log on each side, now I can use the one-to-one property. And of course that takes you right to that step. So, said most of you probably like that. You think, well, that's a lot easier. Yeah, it is, but be very careful because it's a very common mistake to not combine those two together. But there is homework for 3.4. If you have further questions, you're always welcome to come in.